All right, in this video, we are going to be taking a look at exponential functions and more specifically, just the standard form of exponential functions. All right, so exponential functions, the easiest way to describe them when we're looking at the formula for an exponential function is that it has a variable in the exponent. So right down here, I've written two different equations. We've got f of x equals x squared, and then we have f of x equals 2 to the x. Again, if I want to identify which one of these is an exponential function, well, which one has a variable in the exponent? Obviously, this first one, f of x equals x squared, does not have a variable in the exponent. The variable here is just the base. All right, and we know this is a quadratic function. Obviously, it's not an exponential function. So this second one here, this f of x equals 2 to the x, we see 2 to the x is in the exponent. That is going to be our exponential function. All right, so our standard form for an exponential function is written down below here. We have f of x is equal to a times b to the x. All right, a times b to the x, and we're really just filling in for a and b, and we're going to talk about what each of those kind of does to the function. All right, this a value, starting off with a is our initial value. All right, a is our initial value. So remember that our initial value is just our y value when x is equal to 0. And let's think about why that is. Why is my a value the initial value? Well, if I plug in 0 for x, right? If I plug in 0, I would get f of 0 equals a times b to the 0. I know that any number to the 0 power comes back as 1. So I would get f of 0 equals a times 1. So f of 0 equals a. All right, so that a value there is just going to be our initial value. It's going to be our y-intercept. All right, and the one thing we know about a is that a cannot be equal to 0. Okay, a cannot be equal to 0. In real life scenarios, a is usually going to be greater than 0 because we're dealing with a positive number of things. We're not really dealing with, oh, there's negative 6,000 people that live here, right? We want, most of the time when we're using these real life scenarios, we're going to have a positive a value. All right, but a can't be equal to 0. If it is equal to 0, well, 0 times anything is equal to 0, so it's not really going to do anything for us. All right, and now regarding our b value. So b actually has some more specific restrictions to it. All right, first of all, b is our growth factor. All right, b is our growth factor. It's what we are going to multiply the previous value by to get to our next value. So if I know like f of 2 is equal to 3, and then f of 3 is equal to 12, well, I know that I multiplied by 4 here, so that's my growth factor. I'm multiplying by that growth factor of 4. So my b value would have to be equal to 4 in that situation. All right, so b is our growth factor, and then we know a couple of things about b. First of all, we know that b has to be a positive number. Okay, b has to be greater than 0. The reason for that, think about what's going to happen if it's a negative value. If I were to plug in if I said negative 2, well, negative 2 squared is going to come back as a positive. Negative 2 cubed is going to come back as a negative 8. What's going to happen to my graph? It's going to be all over the place. It's not really going to make any sense. So my b value has to be positive. It has to be greater than 0. And then the other thing that I know is that b cannot be equal to 1. That's the other restriction on b. Again, let's think about why that is. Well, if you do 1 to the first power, it's 1. 1 to the second power, it's 1. 1 to the third power, it's 1. it's not increasing there, it's not decreasing there. That's just going to be a flat line. That's a constant. All right, so we're not going to use an exponential function in order to describe a flat line. That doesn't make sense. So b needs to be greater than 0, and it's not going to be equal to 1. And again, that b represents our growth factor. We'll kind of see how that plays in a second. All right, so exponential growth is going to occur when that b value is greater than 1. So my function is going to be growing when my b value is greater than 1, and we will see that soon. And it's going to be decay when my b value is less than 1. Of course, we know it has to be greater than 0, so if it's less than 1, it's going to be decaying. Well, imagine that I have some f of x is equal to 9 times 2/3 to the x. Well, this is telling me my growth factor is 2/3, so every time I'm multiplying the previous value by 2/3, yeah, it's going to decrease each time because I'm multiplying it by a number less than 1. All right, so let's use a chart just to take a look at my exponential growth and exponential decay. So this first one, I have 8 times 3/2 to the x. So I'm just going to plug in some values here. Here's my x, here's the f of x that I get out. Let's start just by plugging in 0. Okay, f of 0 is going to give me 8 times 3/2 to the 0. Well, that's 8 times 1. 8 times 1 is just 8. Let's do f of 1. Okay, let's just go up to, let's say 4. Okay, things could get a little bit messy. Now, this is going to be 8 times 3/2 to the first power. Okay, well, 8 times 3/2 to the first power, that's just 8 times 1.5. Well, 8 times 1.5 is going to give me 12. Now, let's plug in 2. F of 2 equals 8 times 3/2 squared. 3/2 squared is 9/4. So that's 72/4, which is equal to 18. F of 3, we'll probably just stop here at 3. 8 times 3/2 cubed. All right, that's going to be 8 times 27 over 8. Well, the 8's just cancel, and we're left with 27. All right, so here's a little chart for my f of x here. Now let's see what's happening. This was a multiplication by 1.5. Of course, I know 1.5 is equal to 3/2. Then, again, to get to the next one, I added 6, which was, again, a multiplication of 1.5. And, again, a multiplication of 1.5. So we can see how that growth factor is coming into play. So, again, my b value is what I'm multiplying by to get the next value. And then my a value here, this 8, is my initial value. When x is equal to 0, y is equal to 8. All right, let's do one more chart. This one's going to illustrate some exponential decay for us. So here's x, here's f of x. I'll just go 0, 1, 2, 3 again. If I plug in 0, hopefully I'm easily seeing that f of 0 is going to get me 36. If I plug in 1, f of 1 is 36 times 2/3. All right, 36 times 2/3 is 24. F of 2, that's 36 times 2/3 squared, which is 4/9. 36 divided by 9 is 4, times 4 is 16. And lastly, f of 3, I've got 36 times 2/3 cubed now is going to be 8 over 27. Well, 36 over 27 is 4/3 times 8 is 32/3. All right, so now let's just take a look at this and make sure our growth factor is 2/3. Yep, that one's definitely 2/3. That one's 2/3. And that's also 2/3. So again, we can see the growth factor right here. And then we take a look at our initial value right there. All right, let's finish it out with this example where we are going to write an equation for f of x given its chart. Well, we know f of x is equal to a times b to the x. All right, that's a multiplication right there. All right, well, a is just my initial value. All right, so I start off, I know that my initial value right here, it's when x is equal to 0, y is equal to 8. So f of x equals 8 times b to the x. Now I just need to solve for what's b. Let's just plug in a number. The easiest one to probably use in this situation is 1, 12. So I plug in 12, I get 8 times b to the first. Well, b to the first is just b. So b equals 12 over 8, which is the same thing as 3/2. Therefore, I can write my final equation as 8 times 3/2 to the x. All right, my growth factor is 3/2, and my initial value is 8. And my last problem, sorry about that, guys. I might have fooled you into thinking the one before was our last problem. But we are going to write the equation for the exponential function g of x, given that g of 0 is 16 and g of 2 is equal to 9. All right, so again, I know g of x is exponential because the problem tells me it is. A times b to the x. All right, if I plug in 0, I get out 16, so 16 is my initial value. G of x is equal to 16 times b to the x. And then if I plug in 2, I should get out 9. So 9 equals 16 times b squared. So b squared equals 9 over 16. I take the square root. B equals the square root of 9 over 16, which is just 3/4. All right, so g of x is equal to 16 times 3/4 to the x. That is my exponential function. Hope this helped you guys out. Best of luck as you get to the homework.